Okay, so we need one more block, right? One more block for predictive distribution. Okay, right. And then for forecasting, what do we need? We need independent variables, right? Independent variables that will be used for forecasting, right? So then here, where are the independent variables? Here, okay, here, 1 to n minus 1, right? So this is a one-time lag value, right? One-time lag value. Then say xf. Okay. And here, this must be 1 intercept term, and then last observation is just end. Right? So this is the regressor. Okay, let me make it column vector, semicolon, and here transpose. Okay, regressors to be used in forecasting. So this is k by 1, right? K by 1. So this is a column vector. Okay, this is a column vector. Okay, right. So then, what do we need? We need storage for saving YFM zeros n, 1. Okay. So this is for saving predictive distribution, or just the forecast. Okay. Then we need the block for predictive density simulation. Let me put. Okay, just yeah. Forecasting, right? So then YF, what's the mean? Mean is what? Mean is x underbar f times is small x or large x? Yeah, small x. Okay, small x times beta. Okay, this is k by 1. This is k by 1. So then it should be x underbar f prime transpose. Okay, it should be transpose. Okay, plus rand n 1, of course we have to multiply what? Excuse me, square root of sigma 2 times, right? And then I'm going to save it here, ITR equals YF, or here. And then let me run this. Okay, no errors. And then let's see the values in YFM. Okay, yes, looks beautiful, right? Okay, yeah. So then our forecast is the 2%. Okay, So the house price is expected to grow at 2% annually, right? Okay. Now, okay, so this is forecasting, right? This is forecasting, and then what do we have to do? We have to evaluate its performance, right? So then we are going to choose the hyperparameters, maximizing the predictive accuracy of the of our density forecasting. Okay, so then let's do the out of sample forecasting. Okay, here then okay, here then suppose we forecast the last observation here, last observation. Okay, so then let me define here. This is y underbar full. Okay, and this x underbar full. Okay, so then now let me define y equals y 1 colon and -1, and realized y equals what? Equals, I'm sorry, this y underbar full. Okay, this full sample for the dependent variable. This is the end, last observation. Okay, and then now define x. Okay, so this is the dependent variable. So this is realized dependent variable. X, what about x? Here, now x is the x full. Here, no, this is 1 colon and -1. Okay, comma colon. Okay, so this is the independent variable, right? And here the regressors here. Now this is x underbar full. Last observation of x underbar full will be used as the regressors in forecasting. And transpose. Okay. Right. Okay. I think it's fine. Right. So this is a full sample of y. This is full sample of x. Full sample of x. Right. Okay. Yes. Yeah, I think there's nothing to change. Okay. Let me run this. Right. Okay, here. It should be y, and where cap t is used. Cap t will be used in defining alpha 1, and this and anything else yeah, nowhere else here. So then let me simply put just loss of y. Okay. Right. Okay. Okay, let me run this. Here. Here is k t again. Just loss of what? Y underbar full. Right. Okay. Run again. Yeah, it's running. Right. It's running. And then here. Now let's evaluate the predictive accuracy. Then before then, we have to are we saving? Yes, we are saving the posterior predictive samples, and then of course we have to discard the burn-in period. Okay, right. Right, and then let's compute log PPD, right? PPD. So then here, okay, and then how did we compute it? Log PPD, and then I think yeah we have the code, right? Anything. Okay. Here, this is the. Let me copy and paste it here. Okay, realized and mean, and here standard error. Okay, so then realized y, same. The variable name is realized y. Okay, so this is realized y, and then this one is y fm here, yfm, right? Okay, so this is the predictive density, and then we are going to report log PPD, right? DISP here. Log PPD is num to string here. Log of let me define here log PPD equals log of, let me just set PPD. Okay, log of PPD and bracket here. Okay, all right. Okay, I think yeah, it looks good. Okay, let's run this again. Change folder. Okay, here's -3.238. Okay, I'm just curious this value 0.06. Okay, And what about this? Okay, wow, this is realized growth is the 4%, but the forecast was only 0.6%. Okay, what about standard errors? Yeah, standard errors are quite large. Yeah. Okay. Right, looks good. Here, okay, let me show you the predictive distribution. Okay. Okay, here this predictive distribution. So mean was just 0.6 like this, 0.6 like this, but realized growth was about here, 4%, right? 4%. Okay, here, and then again this log PPD is minus 3.24 about here, and let's try with different hyperparameters. 500. Yeah, very similar. Okay, right. All right. Okay, pre-try this code.